separated it to where it was just equal to y, so I had y equals 5 minus x cubed over y squared minus xy. And then I had to do motion rule. And then I should have just done the derivative at the start.
I thought I had to do product over x and y squared.
You shouldn't have to. Yeah, you did.
What did I not do?
No, you did. You did the product rule for
Yeah, right here.
x, y squared.
Yep. So 1 y squared, and then, oh, but you know what? This should have a negative sign. Like that is what it should be. So I need to go adjust my signs here. That should be minus.
Oh, I just wrote it weird.
And then you forgot the 3x squared.
Oh, yeah, I sure did. I didn't even see that.
Oh, okay. Now it's looking more fuzzy.
So plus 3x squared. Okay. And then plug in 1 and 2. But this is the big part of the work, right? Sorry. Did you do it?
Yeah.
Okay. So what would that be? 4 plus 3. Any of these start with a 7? Nope. Oh wait, that's not. Sorry. So 2 squared is 4. Yeah, that's 3.
7 over, but it could simplify.
Good point. And then 3 times y squared, that's 6. 6 minus 4 is 2, so 7 has. No. Alright, so where's the issue?
Yeah, because wouldn't you have to like?
Mine is on the bottom.
Well, you would have to subtract, or yeah, you would have to add the y squared over on the other side because it's right there. But did you do?
Where is your
2x
5?
y dy dx. Well, the derivative of 5 is 0.
Oh.
I see it. It's this. This x squared I made minus for some reason.
Oh yeah.
And then so it should be minus there. I don't know why I wrote it as minus. That's weird. Alright, so 4 minus 3, there's 1. And then what was our denominator? It was 2?
1
What the heck?
Wait, there must be like something with the plus.
I feel like I'm just trying to go too fast, probably.
I'm gonna do it the way that I'm supposed to do it.
Me too. So 3y squared dy dx minus this whole thing, which is y squared times 1, plus the 2y with an x dy dx plus 3x squared. Any issues with that you guys see?
No.
Did I have that as a minus? That might have been it. I don't know, I'll just do it again. 2 squared is 4, so 12 minus 2 times 1 times 2, so 12 minus 4, so it's 1/8. There we go.
Yeah.
I'm not, I think I had the sign maybe wrong on the y or something. Anyway, so 1/8. So product dy dx stuff. Good. Any questions on it? These, by the way, I tried to pick ones that are representative of things on the test. Do you want to do another implicit?
Yes.
Okay. Oops. I'm going to try to zoom this just a bit. There we go. Okay. So for this one, I would maybe call this u. So we have sine of u. That says su. And then that side is fine. So we'll get cosine of u. And do we need a dy dx there? Well, we're differentiating the sign with respect to x plus y. So it's okay. Anyway, so cosine of u, and then do the inside, so times 1, or plus dy dx, 1y, so just y. And then cosine of x plus y.
Wait, why 1 more?
You're right, it's just 1. Yep. And then 1 plus dy dx equals 3 minus 2 dy dx. Okay? Are you guys good if I distribute that on this step?
That's what I did.
Yeah. Instead of rewriting? Okay. And then let's do, huh?
Subtract the cosine.
Yep. And pull out or factor out that. Okay. So it's the same as this one, just with the 2 in a different order once we divide.
So how did we get 2 cosines?
Say that again?
Like, where did the cosine come from? How did we get that?
You distributed it.
Yeah.
So that's
So this whole thing times 1 and times dy dx.
if you want dy dx by itself, you have to distribute.
Yeah. Any questions, Stone? You good?
Wait, so like the cosine, like how does it? I'm still lost.
Okay.
How did it? Or like how? Why is there 2? Like I keep asking. I know you just explained it, but.
That's okay. Well, like here, maybe I should have done this. That's a dot. Because chain rule, so we had to do the sine derivative and then the inside using the chain rule. So it's multiplication. Then I substituted, so sine of u, where u is x plus y. So I substituted u back in.
Oh.
Right here, this cosine of u is x plus y. So I substituted that back in. And then this thing I circled is still times both of those. So just distribute cosine of x plus y times 1, cosine of x plus y times dy dx.
Okay.
And then, yeah. Is that good?
Yeah.
Okay. All right, next one. I don't know if I can make that much bigger. It always looks good on my screen, and I think I have it big enough. All right, the graph of a decreasing differentiable function f is shown. Also shown is the line tangent to the graph at the point 46. So this is an inverse one. Let G be the inverse of f. Which of the following statements about G prime, I'm going to write that because it's weird looking, about G prime is true? And G equals f inverse.
Oh, okay, I see. So. Equals.
Accordingly, oh well. So that one is C. So take the slope of f, take the reciprocal, and flip the two input, the input and output. Good. So another inverse, like I said, there's a fair bit of inverse derivatives on here. This one is kind of a just plugging in the formula idea. Do you want to do this one, or do you want to keep looking?
Do it.
Okay. Yeah, this is a good one, I guess. This one's kind of annoying because you don't actually need this.
Yeah, I didn't do any math.
Yeah, it's basically just the definition, or the derivative rule. All we have to do is figure out what this is, right? So it's for G, this is G prime equals d dx of f inverse, which is this whole mess. So at 2 is 1, is negative 1 I mean. So it's just v.
Whoa.
Because we're just,
Plug it into the.
yeah, f inverse of, this would be, if we write it out, f inverse of 2 is 1.
I mean, G prime
Negative
of 2
1.
is also negative 1 over, or negative 1 over 24. Because I did do.
Oh, you actually did all that?
Yeah.
Yeah.
Because then I found the derivative of n.
Yeah, I didn't look at the answers before they started.
Okay. Well, if you didn't, I guess at this point you would just take the power rule derivative of that guy
Yeah.
Yeah,
and
that
plug
one.
in negative 1.
Oh, there you go.
You're plugging negative 1 through.
2.
No, we would
No,
plug in
you
negative
have to
1
do your inverse.
into f prime. Yep, so
Oh,
Because-
what's, oh, yeah,
yeah, because f inverse of 2 is
it's
negative.
negative 1.
Then that goes in. Yep. These are kind of weird, huh?
Negative 1 is 3.
Yeah. Okay.
Right.
Here's another one. This is a table one. I think we should take time to do this one too.
First draw.
Well, this is basically just remembering the formula. So see if you can do it without.
Sine it has a square root in it.
Yeah. See if you can do it without looking at your card.
Let's just speak.
So what would this one be?
Tangent.
That would be inverse
Or,
tangent,
yeah,
derivative of inverse tangent. And then that's the correct one, because it's 1 minus x squared in a square root. And then these ones are kind of just nonsense, based
So
on
all
what
the
we
ones
know.
with the S is the one that has the square root.
Yeah.
Yeah.
Yep, so this is 1 over the square root of 1 minus x squared. And partially why I put this on here is just to remind you of that notation too. The bar with the x equals, just remember that's evaluated at x equals 1/2. It's the same idea as if this had a function name and it was like f prime of 1/2, if this was f of x or something, right? Okay. We've done some implicits. So this should be a quicker one because it just says which one needs implicit differentiation.
You see, that's only one where you have 2y, or 2y dot, 2,
A y and an x.
well, but like 2 separate cases of your
So
y.
why is it not A?
Because you could just solve for y and then take dy dx.
Okay, good. So because it's set equal to 0, we could do that, or think of moving the rest of it over. Maybe I would probably prefer that you did it that way. Move all this stuff over to isolate y. And then c is the only one that y is trapped up into the function, right?
Yeah.
If we want to say it that way. Christian, just real quick, we did just a plain old inverse sine derivative. And kind of the strategy that Aiden said, inverse sine derivative has a square root, and in this case there was only one of them that did, so it kind of directed our attention there, and it was correct. And then just real quick to ask you, do you remember which one that would have been? Yeah, good job. All right, quotient rule, basically the same question on the quotient rule now.
I see.
And it says be considered the best method.
Oh. I get you. Let's use preference. Because I would have done it for both of them,
I know.
for B and D.
Me too.
For b, couldn't you multiply 2x plus 1 times x to the negative 1?
Yeah. And I think since that's such a simple denominator, it's probably better to do it that way.
You can even just go 1 over x and 2 plus 1 over x. That's easy.
That's definitely a good way. Yeah.
Maybe I wouldn't use quotient. Actually, I would. I just wouldn't think about it until after I did it.
Yeah. Yeah, I agree. We're just doing D. What rules would you use here?
Power rule.
What did you say?
Power rule.
Power, because that says negative 1/2.
You could just put the negative 1
And then you would also have to do.
You can't do that.
to the. Oh, no?
Yeah, did you mean like do that?
Oh, yeah.
Yeah, you can't do
Yeah,
that.
I could do that.
No.
Oh.
Why?
You have to do exponents first.
Oh, because, yeah, I keep remembering, when I have problems like that, on my paper, I do like 2 squared plus 3 squared, and then I do that, and then I do 2 plus 3 squared, and I realize I'm not both different.
Okay, that's good. That's a good way to check it. So it would require the power rule, and then chain rule to get inside, and then just the regular derivative of a constant multiple. Good. How about C?
Well,
Chain
you're-
rule. Huh?
Yeah.
If we had to do the derivative of that one, it would be.
That inverse.
Yeah, that
Yeah,
is.
would suck.
I don't know why these don't show up good, but inverse sine of, yeah. So you'd have, at least it's not secant, because then we'd have that weird absolute value of this whole thing. But so 1 over square root of 1 minus this whole thing times that times 2.
Whatever that.
It wouldn't be too bad, I guess. All right. What else do we have? So yeah, let's try one of these. D4 dx to the 4th.
Yeah.
Okay. And while you're working on that, I'm going to try to make this bigger.
Derivative of ln of x is 1 over x, right?
Yeah.
Yes. B?
Yeah.
Yeah, and definitely this is easier to do as 2x to the negative 1. After your first one, I mean. and then just run it as that. So you end up negative 12x to the negative 4. Good. All right. Figure shows the graph of f prime. It says it there. The derivative of f, at which of the 4 indicated values of x is f double prime the greatest? I don't know if you guys remember in pre-calc, but that word is kind of, I think, a little bit vague or misleading, because greatest probably means greatest positive, not just absolute value greatest, because you could argue that D is probably similar, or maybe even more so. But it does want greatest positive, so I agree.
Well, I mean, if it would want like the greatest in general, it would probably say
Yeah, like if this was, like Aiden said, if this was an in-context problem and it said when was the acceleration, how would it word that?
Changing the fast. Or no, it would be.
When is the velocity changing the most or something?
Yeah.
Yeah. Okay. Then that would leave it open for negative or positive. Okay. Good job on that. These are good to do. Remember, now we're evaluating, so we're doing a double derivative implicitly. So definitely we should do this one. Yeah, I put a star by it.
Because it should be like, maybe I just messed up in my 1 point somewhere. It should be 16 plus 14. It's 30.
So we already have one derivative of f, essentially. Right. So, or of y, I guess, technically, of both. So we need to take the derivative of the one that's given there. So if it helps you, you could define u or whatever letter you like as that inside, and then this would be 4 root u times du dxy, like we're doing it. We have to do it relative to both. So I'm just going to write times du. Okay, so 4 root u, the 4 stays, and we get over 2 root u, which is 1 over 2 root u. Sorry, 2 over root u. 2 over root u. Everybody good on that part?
Yeah.
Are you good on that part? Okay, and then times, and we have 2y dy dx plus 7x on that.
Yeah.
Yeah. Oh, well, while I'm here, let's just substitute in dy dx. Remember to do that?
Yeah.
Oh, that's how you do it. That's what
Okay. So a couple things. I have told you this, and I don't know why, but this is just me. I always do my math symbolically and plug in at the end. And I'll be honest, that's not a great testing strategy because it's slower. But I just like to see it play out first. I could plug 1 in here right now, right? Well, these two things, actually. I could plug those in there now and not bring that whole mess right here and just have a number instead. So let's actually do that. So dy dx at x equals 1. And 3, there it is. So 3 squared 7 times 1 squared. Did you say this whole thing is 16?
Yeah.
Yeah, because 9 plus 6 plus 7, so. Okay. Anyway, if you can kind of separate that out and save yourself a little bit of writing. I think what I'm going to do, just for the work here, is leave it for now. And then we can just start plugging in stuff. Just so I have the plugged in equation. But so y is 3. This was 16, right? This whole thing?
Yeah.
That's okay. I'm just going to write it. Minus 16 plus 14 times 1. Okay. I'm hoping that this isn't what you did and got 94 for a reason. Is it?
That's exactly what's happening.
Uh-oh.
Is that?
So this is 2 over 4. And then 6 times 16 is 96.
Maybe it's like
Plus 14 is 110. So half of 110 is 55.
What? Because I did 2, and then that's 12, and 12 times